Hi guys, in this tutorial I'm going to solve question number 7, paper 42, June 2019. A particle P and Q leave a fixed point A at the same time. Fixed point A, particle P start to move, and particle Q start also to move from a same point, fixed point A at the same time, and travel in a same straight line. The velocity of P after t seconds given by velocity is a variable in terms of time, t minus 3, and velocity of Q is 10 minus 2t, same time. Sketch on the same axis the velocity time graphs for P and Q from 0 to t. It's a function. One is a linear function and the second is quadratic function. You have to show that the first is quadratic. It's better to identify the turn point, the intersection with the x-axis, the intersection with the y-axis, and he asked to sketch from 0 to 5. So the start point is 0 and end 5. So please, for this quadratic function, you can find the turn point by using completing the square form, by using the differentiation and equating with 0. I will use differentiation method. If you expand, will be 6t squared minus 18t. To get the derivative, dv by dt is equal 12t minus 18 equal to 0. Solve the equation, find the value of t, 18 divided by 12, which will be 1.5. So the turn point will be at exactly 1.5. You can find the y coordinate if you substitute in this function with 1.5, 1.5, 1.5, or after expanding will be 6 times 1.5 and 1.5 minus 3. So the turn point at negative 13.5. Negative 13.5. And the intersection with x-axis, by substitute t0, you will get t0 and you will get it 3. It's a line of symmetry at 1.5. So the graph of this function will be like this, as U shape, and move up till 5. 5, it's better to get the corresponding value at 5. Substitute in the original function with 5, you will get 6 times 5 and 5 minus 3, so the answer will be 60. This is the first function. Quadratic, show the start point from 0 to 5, the turn point at 1.5, negative 13, show the intersection with x-axis at 0 and 3. This is the first function. Second function is a straight line. It's a straight line, intercept at 10. So the line, inclined line, started from 10, then move down to cut x-axis exactly at 5. When you use y equals 0, you will get t is equal to 5. This is the first part. You have to show the velocity start with 10, decreasing till 5 will be 0. This is the graph of the first function and the second function from the interval 0 and end with 5. Asked to sketch on the same axis velocity time graph for P and Q for t more than 0 and less than 5. This is the first part. Second part, verify that P and Q meet after 5 seconds. Meet after 5 seconds, this means you have to show that SP is equal to SQ at t is equal to 5. You can use integration method to get S of P and integrate of S of Q. Then you have to show that both are equal. Let's start with P. For P, the integration from 0 to 5, integrate from 0 to 5, the expression is 6t squared, 6t squared minus 18t, 18t by dt. 6t squared minus 18t, then start to integrate, will be add 1, will be 3, divided by new power, 6 divided by 3 is 2, minus t, we add 1, divided by new power is 9, from 0 to 5. Substitute by 5, then substitute by 0, 2 times 5 to the power of 3, minus 9 times 5 to the power of 2. So the answer will be 2 times 5 to the power of 3 minus 9 times 5 to the power of 2. So the displacement is equal to 25. By the same way, for SCQ, you can use integration method, integrate from 0 to 5 your function by dt. The function is 10 minus 2t, 10 minus 2t. Find the answer will be 10t after integrating, add 1 divided by new power from 0 to 5. Substitute by 5, 10 times 5 minus 5 squared. Minus 5 squared. So the answer will be 50 minus 25 is also 25. You can show that the distance under the curve and the x-axis by finding the area of triangle is half, base is 5, height is 10, you will get the same answer. This means you verified that both at the same distance, which is 25. Verify that P and Q meet after 5 seconds. The third part, find the greatest distance between P and Q. Find first the distance between P and Q, which is equal S of P minus S of Q. We already can use S of P after integrating. If you integrate it, you will get this expression, and integrated this expression. So the distance in between is 2t to the power of 3 minus 9t squared minus 9t squared minus S of Q, which is 10t minus t squared. This is the expression of the distance. You can simplify it. 2t to the power of 3 minus 9t squared minus 10t plus t to the power of 2. Simplify 2t to the power of 3 minus 8t squared minus 10t. This is the expression for the displacement. To get the greatest value means the stationary for this expression, use differentiation, will be 6t squared minus 16t minus 10 is equal to 0, and solve your equation to divide it to get the values of t. You can use your calculator direct to solve this equation. So the time will be, the first time is 3.189, second time is negative, whatever the value is rejected. So this time has the maximum. He asked to the greatest value. If you substitute now in the expression of the displacement, in this expression, by using the t is equal to 3.189 or exact value, if we substitute by 3 in this expression, so 2 times 3.189 to the power of 3, then minus 8 times 3.189 to the power of 2, minus 10 times 3.189. You will get the answer is 48. It's given negative, but its magnitude will be 48.4. 48.4 This is the value, the greatest distance, 48.4, as the magnitude or the difference in between. Find the greatest distance, because if I got SC minus SQ, but you have to get the magnitude, whatever the value is positive or negative, you will get the final answer is 48.4. That's it. Thank you.